colleagues at ANU on the passage of a dear friend and colleague, Helen James. Helen was instrumental in setting up the Institute and in getting me involved with it. And I know you all join me in missing her very, very dearly. What I'd like to do this afternoon is to talk a little bit about the changing nature of hazard and disaster risk, especially at this particular time in the world history. Before I do that, however, I want to briefly talk about where we are in terms of our understanding of hazards and disasters and how this traditional view has changed over time as circumstances and our knowledge changes. Initially, at least in the North American context, the traditional view of hazards and disasters was one where you basically had the natural systems that interacted with the built environment. You had natural systems interacting with the social systems, and this created a disaster, what we know as a disaster. So you would have an earthquake that would affect the built environment, it would affect the social systems, and if that earthquake was large enough, it would create a disaster. And most of our understanding started with the physical systems. And so you can see it's a one-way direction from the natural systems impacting the built environment and impacting the social systems. Very early on, Gilbert White, a famous geographer and for many in North America called the grandfather of hazards research, in 1942 realized that while the flood itself was an act of God, the losses or the impacts of that flood were acts of people. And so as early as in the 1940s, we begin to change the understanding a little bit of hazards and disasters and realize that they are social constructions and they do not exist independent of human activity. If you don't have people involved in the picture, you don't have a disaster. And so we've developed a more influential and process-oriented understanding of the social construction of hazards and disasters, where we still have the influences of the natural systems on the built environment and social systems, but we have these broad social and economic and historical processes that influence the natural systems themselves, but these broad processes also influence the built environment and the social system. And as an example of some of these broad processes, what we're looking at are things like urbanization and globalization, and how that has affected and changed the natural systems, which in turn then influence and are influenced by the built environment, the social systems, to produce the disasters. So what we have is a change in our understanding from a strictly physical perspective to one that's more socially constructed here. But we see in the 1980s and 1990s a new idea coming forth in what is called the vulnerability paradigm. And this is focused on the work largely of Ben Wisner and colleagues. And it looks at how vulnerability progresses from the root causes of the vulnerability, which you can picture in this formulation here, moving to these pressures, these dynamic pressures, which come from these broad historical patterns and processes to produce the unsafe conditions. And the unsafe conditions then interact with the natural hazards. And so increasingly what we look at in terms of hazards and disasters and changes is within this notion of the vulnerability paradigm. More recent, we've discovered that we have different perspectives that we bring to understanding hazards and disasters. And this is focusing on moving from purely disciplinary perspectives here, going to multidisciplinary perspectives, to interdisciplinary perspectives, where you create new knowledge by bringing the disciplines together, to now more transdisciplinary perspectives, which engage the communities. And you co-produce the knowledge and the understanding by involving the communities from the beginning of the process. And so we've moved from a very static approach to hazards and disasters to one that is socially constructed, where now vulnerability is the centerpiece for our understanding of hazards and disasters. And this is done in the context of interdisciplinary and transdisciplinary science. What this means in a practical sense is we now recognize, both from a research and from a practitioner perspective, that there's no such thing as a natural disaster. And much of the work of the UNISDR is focused on getting rid of this terminology, natural disaster, from the glossary, because there is no such thing as a natural disaster, because disasters by definition involve the intersection of human systems, the built environment, and natural systems. So what we see now is the severity of disasters is now measured by the magnitude of the impacts on society, not just the physical forces themselves, the amount of energy released, for example, in a earthquake, or the amount of wind speeds in tropical systems. It also means that we now begin to focus our attention not only on discrete singular events, but increasingly on common and everyday events that are a result of these ongoing processes that are changing the landscape and are affecting societies globally. What I want to focus on briefly are three considerations, three main points that I want to make in this lecture. The first is that singular large extreme events do have consequences in specific places and in specific times, but they may be less impactful in the longer term than these lower level chronic events that happen time after time after time. The second consideration is this notion of cascading disasters are now really the norm in what we see in a global context. And these cascading disasters have consequences that extend well beyond the immediate location and time frame of the event itself. And the third consideration is that we continue to see inequalities persist in the impacts of hazards and disasters. And these inequalities are increasing and in some instances accelerating beyond the capacity of places to cope with them. And so what I'd like to do is to illustrate each of these three considerations. The first has to focus on what we mean by extreme events and extreme consequences. And we can define extremes in a number of different ways. We can define them statistically using statistical thresholds. This is what you often see in the climate change literature, which identifies extreme events as being in the 95th percentile, for example, in terms of precipitation or in terms of temperature, for example. We can define extremes based on the human consequences. And here there are a number of ways in which people have defined these in terms of looking at monetary thresholds. There's a product in the United States called the $1 billion weather disasters. Why they assumed $1 billion was a particular threshold for defining an extreme event is unknown. But that's one way of defining it, as is in health-related instances, excess mortality. That is the mortality we would expect to be above what would normally occur. And that could define an extreme public health event, for example. We also have different ways of describing these events themselves, which allow us to actually develop some type of comparisons as to whether or not the events are frequent or rare. We can talk about these events as being slow onset events or fast onset events. We look at whether or not they are temporal in their spacing, that is, do they occur with some kind of regularity like seasons, fire season, for example, hurricane season, typhoon season, or are they more random kinds of events, which is what you see in the case of many geophysical events. If you broaden it beyond the natural context, we also see the exposure type. There are many types of extreme events that we are exposed to involuntarily as opposed to voluntary. And so one of the ways in thinking about the changing nature of hazards and risks is we've started to describe what we mean by extreme events and how we actually describe the hazards themselves. And so one of the first questions that I pose is whether or not extreme physical forces always produce extreme consequences. In other words, do you need an extreme event to produce extreme consequences? And what I have put here on the chart is just a sample of an event in a particular place that shows that, yeah, it looks like in some instances, these extreme physical forces do produce extreme consequences. Hurricane Maria in Puerto Rico was a Category 5 storm on the Saffir-Simpson scale. It did create excess mortality on the order of 3,000 people who lost their lives in that event, although those numbers are subject to some discussion. And it caused an enormous amount of damage, structural damage, property damage on the island itself to the tune of about $92 billion US. Similarly, Hurricane Harvey in the city of Houston was not as large a storm. It was a Category 4 storm, but it was a stalled system that produced enormous amounts of rainfall that led to extensive flooding in the area. While the mortality was relatively low, the damage was very high. And so from a damage perspective, this would be classified as an extreme event, a $1 billion event. And also from the physical forcing, it would be considered an extreme event given the amount of rainfall. Similarly with Hurricane Dorian in the Bahamas last year, similarly Category 5, the highest on the Saffir-Simpson scale, less damage in terms of dollar losses, but if you look at the relative impact of that $5 billion loss on the GDP of the Bahamas, it was significant. Typhoon Hagibis in Japan, another example. And then the last example is a heat wave in 2019 in India and Pakistan, where you had extreme heat over 49 degrees Celsius for 3 weeks or so, relatively little damage to property, buildings and so forth, but some excess mortality. So we can say that extreme forces do produce extreme consequences. But do we have non-extreme physical forces that produce non-extreme consequences? Well, this should say actually produce extreme consequences rather than non-extreme consequences. Examples here are Hurricane Katrina, which from a physical perspective was not a major, it was a major hurricane, but not at the Category 4 or 5, yet it produced an enormous amount of damage and excess mortality. Hurricane Sandy, which was a Category 1 storm, was also not extreme in terms of the magnitude of the storm, but the impacts, the consequences were on the extreme scale. Similarly, the Camp Fire in California, which was one of the costliest fires in the United States. And then, of course, your Black Summer, which again, may not have been extreme because fires have been periodically and frequently in Australia as they do in the Western United States. But the size was the parameter as well as the damage impact. So what we do see is that these singular large extreme events are consequential in specific places and in specific times, but some of these less extreme chronic events, and I would put fire in that category, may in fact be more impactful in the longer term. And what this suggests is as we continue to alter the natural systems at local to global scales, we can see that extreme events that would happen occasionally now may be produced on an annual, seasonal, monthly, or everyday occurrence. Extreme events like sunny day flooding or wildfires or heavy precipitation events may become more frequent in the future because of the human alteration of the natural systems. So what we considered to be an extreme event 5 years ago may in fact no longer be an extreme event. It'd be something that we anticipate on an annual basis or on a seasonal basis. We also see that, again, because of population growth and demographics and the spatial distribution of that population, there are more people at risk, and this means that the antecedent conditions, that is the pre-existing conditions, will in fact increase the impacts, both in terms of the location and perhaps the timing of those consequences. And where you see these continuous impacts because of the seasonality shifts, where the extremes become more closely related to everyday or chronic events, there's actually insufficient time for communities and locales to recover before the next extreme event. And so part of what we are wrestling with as we move into the new decade is, how do we handle this notion of extreme events? And how do we classify the suite of hazards and disasters? The Sendai framework for disaster risk reduction starts this process by looking at small and large scale events, by looking at events based on frequency of their occurrence. Are they infrequent or frequent? And are they slow onset or are they rapid onset? Because how we manage these events and how we manage these disasters going forward has a lot to do with the characteristics of the events themselves in terms of these parameters: the frequency, duration, widespread nature of it, the area covered, the speed of onset, and so forth. So this is my first consideration, is the changing nature of extremes and their impacts. The second consideration is that cascading disasters are now the norm. And these cascades extend well beyond the initial area where the event took place, and beyond the initial timing of when that event took place. And I have a couple of examples for this as well. What we see is there's a renewed interest in cascading hazards. A lot of this innovative work is being done by University College London and colleagues there, particularly David Alexander. And it's looking at a number of different facets of these cascades. But what we're seeing is, because of the globalized systems and the increasing interdependence of these systems, what we have is an increased potential for disruption of both regional and global economies, as well as increased potential for bigger and more humanitarian crises. Going back to the first point, what we're going to see is more extreme events. And extremes are in scare quotes because these extremes are now morphing into regular events. We'll see more extreme impacts and consequences that arise from even less extreme events. And this is related to looking at intensity versus impact determinations. And what we're also seeing in focusing in on these cascading hazards is that we have limits in our disciplinary understanding of practice and policy in how we actually describe these processes and these events themselves, which is pushing us towards this transdisciplinary and interdisciplinary understanding of cascades. Depending on which community you do your science, whether you're a natural scientist such as a geophysicist or a hydrologist, or if you're a geographer, you call these cascading events different things. One notion is hazards as compound events, where event 1 leads to event 2, which leads to event 3. This is what is often termed the toppling dominoes event. There's a very linear progression, and the attribution that event 3 was caused by event 2, which was caused by event 1. This is the traditional notion of cascades. And what you have is this kind of schematically, you can look at it linearly, you can look at the causal pathways for these compound events. A classic example is the San Francisco earthquake in 1906, shook the city of San Francisco, caused some damage, but most of the damage and the consequences of the earthquake were the fires that resulted because of the burst gas lines and the fact that they couldn't get the firefighters into the area to put out the fires from the wooden structures in the area. Another example of a cascading event happened here in my backyard, actually. This was a flood in South Carolina, the so-called 1,000-year flood. And what you had, this is a highly urbanized watershed that has a series of ornamental dams. And these ornamental dams started to fail because of the amount of precipitation in the area over a very short period of time. And so you had the domino effect of the dams up here failing as they're going down the stream course, ultimately flooding up to the roofline areas downstream in this area with some loss of life, but it paralyzed the city for over a week. We also see instances of natural hazards are triggers for industrial accidents, the so-called NATECH events. And here you have industrial facilities oftentimes located in coastal areas or in riverine areas. And you have a flood, flooding a chemical facility with water-soluble materials. And what you see is you can have fires, you can have flooding and chemical releases. And these kinds of events really make emergency managers nervous because they don't often know what's being stored in these facilities nor how to respond. And one of the ways in which to mediate the impact is for evacuations, but it's hard to evacuate a population in the middle of a flood. In the same way that we try to not have people living around these facilities. You can see here, this is a photograph of a fertilizer plant along the Mississippi River, and it ended up releasing all the fertilizer and the chemical components into the river, contaminating the river downstream, which was also a source of drinking water for many communities. And then more recently here, we have industrial production of hogs. And so what you have is the flooding of the hog farms and all the release of pathogens, actually, from the hog waste into the watercourses as a result of the flooding. So this is an example of that, a cascading event or a compound hazard. We also see that there are anthropogenic stressors on the natural systems as well, which create cascades. Some of this is related to what they call blue sky flooding, which is tidal flooding. You have increasing urbanization of the wildlands, and so increases in the wildland-urban interface. This is the Paradise area with fires in California. And then you have human interventions in oil and gas drilling through the process called fracking, which is increasing the seismicity and the number of earthquakes in Oklahoma, as one example. People who study the cascading disasters move our understanding beyond the simple linear pathways and derive some of their understanding through the work of Chick Pero and Ulrich Becht on the Risk Society, and look at the interdependent, interconnected natural and socio-technical systems and how they function. And it's this complexity and interdependence that leads to unexpected failures. And these failures then create even more social dependencies, and the impacts increase over time well beyond the initial source region. And what we see in many of these instances is that the historical vulnerabilities in places amplify the impacts of many of these cascades. A couple of good examples of those kinds of events are the Icelandic volcanic eruption that basically halted airline traffic worldwide in 2010 and disrupted global supply chains and throughout Europe and North America. We also see in 2011, the Thai flooding had significant impacts on Thailand itself, but again, there were global impacts because of the global supply chains and the number of companies who were affected and the total losses. So even though it was localized flooding, it cascaded globally in terms of its impacts because of these supply issues, just-in-time manufacturing, and so forth. One thing that we haven't seen as much is an idea that I've thought about, which is what we call the social cascades, which suggests that there are these accumulations of social and economic and political effects that happen when repeat disasters happen in a particular place time after time after time. And that this sort of repetitive nature of events actually creates a kind of a perverse multiplier effect, which reduces the capacity of that place to adequately prepare for, respond to, and recover from a disaster event. And it, in many, many ways, puts a boundary condition or limits on mitigation and longer-term recovery. Clearly, the poster child for social cascades would be Puerto Rico, with the number of storms that have affected that area, where the whole history of that island, its inability to recover from the first storm leads to reduced capacity for the second, which leads to reduced capacity for the third, is one example. There's also something new that I hadn't seen until the fires in California, and that is that the utility, PG&E, in preparing to mitigate the fire, has decided when there are high wind advisories, Santa Ana wind advisories, they will shut down power in selected areas throughout the state. And without thinking, when you shut down the power without a lot of notice to communities that have facilities that and households that rely, for example, on medical devices for breathing, then you are putting an additional group of people in harm's way because of the power shutdown, where they can't get the ventilators that they need. They can't get the CPAP machines that they use at night. They may be on oxygen, which requires electricity and so forth. So these social cascades manifest themselves and trickle through society in ways as a secondary and tertiary impact from an initial event or an initial mitigation. The third consideration I have that I want to share with you is that the inequalities in disaster risk are persisting, and they're also increasing and pushing places beyond their capacity to actually cope with them. What we see globally is that losses and impacts disproportionately affect the most advantaged in societies. We see at the same time racial, gender, political divides increase and have increased based on these historical processes and patterns and outcomes of the interactions between these historical processes, the built environment, society itself, and the natural systems. And what this is doing is it's segmenting societies into haves and have-nots. We're also seeing that gaps are increasing within these haves and have-nots based on wealth, gender, wage, and technology gaps. And these gaps are increasing the generational inequality that we're seeing. For many parts of the world, the children will have less wealth than their parents. This is particularly true in North America, where my children will have less access to wealth than their parents did. We're also seeing this play out in terms of who can get out of harm's way, and the impact of large storms, for example, on poor people who can't relocate, who lack the resources to relocate. We see in terms of institutional resources that there are inequities in who gets disaster relief money. For many, it's only homeowners, not renters. And so if you don't own a home, you don't get help when you're flooded. We also see that recovery for some groups is much harder than others, again, related to wealth, gender, wage, technology, and power grabs and gaps. One example of this is how, in understanding that there are these inequalities, how can you facilitate putting resources where they are most in need and where they have the people who are who need them the most. And the state of South Carolina, after the 2015 floods, decided to prioritize disaster recovery for those residents most in need, which are identified here based on their losses, and those people who were most vulnerable. And so one of the ways to facilitate this, to empirically demonstrate this, using an apolitical mechanism for targeting areas, is the Social Vulnerability Index, which we've developed. In here, you simply do a bivariate map that compares those areas with high levels of loss and those areas with high levels of social vulnerability, and you target those areas here in the dark purple for your resources. The areas in blue, dark blue, have moderate levels of social vulnerability and high levels of loss. The areas in red have lower levels of loss but higher levels of vulnerability. And so very quickly, through the aid of a map, you can tell the story of where resources are needed to support flood recovery. And so this is one of the ways where you can take your science and in actuality put it into practice to help document in an apolitical way the vulnerability and the need. In thinking about these cascades and the inequalities and the extreme events, I wanted to highlight South Carolina for just a moment to show that there are areas in this state that have had 5 storms in 5 years, generating losses that tend to be concentrated in this area right here. You can see on each one of these maps, this same area comes out over and over again. And so this happens to be one of the most disproportionately affected communities in the state with this repeat flooding. And how does a community survive when year after year after year after year it's either flooded or it's burned? And so one of the outcomes that we're seeing with these cascades and the vulnerability is the decline in small towns and the decline in communities that have been there for a while. And what we have is a disaster loss of a way of life in some parts of my state, but this is happening in many parts of the world as well. So what can we say about the changing nature of disaster risk? Well, we can see that these large events are consequential for specific places and times, but in the long run, they may be less consequential than these chronic everyday events, which happen quite frequently. And what we're starting to see is there's a transition on our notion of extreme, where it's now becoming seasonal in some respects. We're also seeing increasing catastrophic damage is occurring as a result of non-extreme physical forces. And so that tells us something about, again, the nature of how we need to think about managing and responding to these types of events. We know that cascading disasters are not unique anymore, that they happen more and more frequently. We know that exposure is increasing as a combination of not only vulnerability, but society's own production of risk itself. That the increasing globalization, industrialization, technology is in fact generating more interdependency, which means there's going to be more increasing exposure and potential for disruption from these cascades. And what it means is there's going to be, in the future, a rise in unintended consequences from some of these everyday events that we expect to occur, like rain or heat or cold. We see the inequalities and disaster risk persist. They're not going down, they're going up in terms of the volume of and number of inequalities. And what we're seeing is the concentration of the risk, unfortunately, at the lowest rung of the wealth ladder. And this is happening in industrialized countries and in non-industrialized countries. And what we're seeing as well is that these impacts are also disproportionately affecting certain subpopulations, both spatially and generationally. And these subpopulations that tend to be most disproportionately affected are in fact women and children. And with that, I leave you thinking about what is the new normal. Is it floods, which is the case in my state? Is it fires, which I think may be the case in Australia? And then, of course, what's left? Thank you very much.